Welcome again to another session on biomaterials. So, we have discussed membranes for plasma separation in our previous videos. So, let us move on to discussing membranes for oxygen separation. So, there's a difference between separating membranes for oxygen separation and membranes for plasma separation. So, plasma separation is basically used for removing toxins from blood. Oxygen separation is actually used to enrich the blood with more oxygen. So, if you take like plasma separation is similar to using a dialysis machine, right? Because hemodialyzer basically removes removes toxins from blood. Blood oxygenation, that is oxygenation of the RBCs or formation of oxyhemoglobin, often occurs in machines such as the heart-lung machine. So, it is one of the most important, heart-lung machine is one of the most important devices for while performing cardiac surgery, because in order to operate upon the heart, you have to make sure that the heart is stopped. However, if you stop the heart, the person's going to die, right? So you don't want that to happen. So you want something to, take over the function of the heart while you operate upon it. And that something is your heart lung machine. So heart lung machine basically takes over the function of the heart and the lung, and it basically oxygenates the blood and pumps it to the rest of the body, and the circulation of the blood is the heart is totally bypassed from the circulatory system, and the heart lung machine takes over. So you also need heart lung, not only in heart cardiac surgery, but also in cases such as septicemia and severe lung trauma. Heart lung machines can be used to provide the lungs some rest and assist in healing, right? So obviously it's a very important discovery as far as medical medicine is concerned, right? As far as medical devices are concerned. And we also know that a number of diseases can be treated by removing toxins and thrombus from the blood, along with a component that trigger an inflammatory immune response. So removal of toxins is very important. We all know that. However, we also know that removal of toxins can also lead to damage to blood cells while we are using plasma separation, while we are performing plasma separation using, membranes or sieve-like structures. So, the first Hartler machine used to use bubble oxygenators and the film oxygenators. So, film oxygenator is basically a sieve through which the blood is passed. We all know what a sieve is, right? It's like the filter that you use to separate tea from tea leaves, right? So, similar kind of a meshy plate through which the blood used to pass, and then there were plates or discs in which pure oxygen or oxygen-rich atmosphere was created. So exchange of gas would occur in these plates, while the sieve would actually allow blood to pass through it and then filter out thrombus, right? So bubble oxygenator, here a bubble chamber is used where the oxygen is dispersed within the chamber. It's an oxygen-rich chamber, and when blood passes through the chamber, it would the oxygen would diffuse into the blood, and there's a defoamer which would remove the majority of the residual gases such as the carbon dioxide. However, both these procedures are not very kind to the RBC and the blood, right? So there's quite a lot of cell damage that is occurring, and therefore a more gentler method was required. So there was a scientist called Clough who in 1940s observed that blood rotating in the drum of his hemodialyzer was turning really bright red when it came in contact with the cellophane dialyzer sheet. So cellophane membrane was used for separating the blood, was used as a dialyzer membrane, and when blood was coming in contact with this cellophane membrane, it was turning bright red, meaning that it was becoming oxygenated. That's when the bright red color comes when oxyhemoglobin increases in the blood. So, observed that this bright red color was because the blood was exposed to open air. So the first membrane oxygenators were made up of polyethylene, cellophane, and Teflon. So this gave birth to the idea of manufacturing membrane oxygenators, because that was improving the quality of blood that was getting into the patient's body. So now earlier polyethylene, cellophane, and Teflon were used, and then later on, yeah, in 1960s, silicone was also used as membrane oxygenator. So, microporous membrane, silicone was, made of silicone resulted in microporous membrane, and they provided excellent performance. But when have I skipped a slide? No, correct. So, but when compared to older silicone membranes, they are more prone to breakthrough. So, you know, older silicone membranes were not as porous as the subsequently developed silicone membranes were, but they they were more sturdy when compared to microporous membranes. So around 2000, the first oxygenator with a membrane from polymethylpentene (PMP) with a very dense outer skin on the microporous body was introduced. So this material was not only microporous, but it had a very dense outer skin as well. So this provided the same level of microporousness as polypropylene membranes, but it did not show the phenomenon of plasma breakthrough, right? So it was not harsh on plasma, but at the same time it was as porous as polypropylene membranes. So polypropylene were quite popularly used initially, microporous membranes, not only through silicone, not only with silicone, but polypropylene was also used. And then this membrane, like the PMP membrane, was very very microporous. It was like very welcoming to our welcoming oxygenator membrane. At the same time, it was not, it was not resulting in damage to the plasma. Right? Plasma breakthrough was not happening. So most blood oxygenators in the modern day are capillary membranes, and they have blood flow outside and the flow and the gas flow inside the capillary. So it just acts like your ordinary capillary in your body, but you have oxygen inside or the gases inside the capillaries and the blood outside the capillaries. So tubular structure. So this would not only reduce the size of the device, but it would also result in effective gas interchange. So most oxygenators have microporous membrane of polypropylene, and 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 so most of them have and many of them have PMP, dense PMP membrane as well. But as on date, according to your textbook, there's only one silicone membrane oxygenator that is still commercially available. So silicone membranes have basically become outdated, and we are moving forwards towards microporous membranes of polypropylene and dense PMP membranes, right? So most of them are capillary membranes that are used because they reduce the size and they do not cause much damage to the blood. So, and they're very efficient in interchange of gases. So I think that's all I have to speak about membranes for oxygen separation. I hope you had a fruitful session learning about it. I shall see you again soon. Thank you.